Well, perhaps it's an intermediate type of change, an intermediate disturbance, if you want to call it a disturbance. That's what helps makes lots of species occur together. And there's where the data really hold up. If you look back at here, you see this small light gap that's formed. A big branch or a small tree fell down there recently and it opened up this light gap. This whole forest is made up of different aged trees and plants because of the light gaps. No place in this forest will stay without some type of branch falling or some type of tree falling 5, 10, 20 years at most. And there are going to be changes, but they're moderate changes. And that makes this whole forest a patchwork of different aged plants and a patchwork of different aged adapted frogs and birds and mammals and other things that can occur only in those different aged patches. And if you look at the overall area here in this forest, no two places are alike. They're all different ages. Patch here, patch there, which allows for lots of different species. Look at all the different species here. There's a whole bunch of species that only occur in open light areas. They're adapted for open light areas and do really well. And the insects and some of the moths that come to these flowers and the frogs that occur here and some of the birds that occur here can only occur in these light gaps. As it grows up, it gets darker and other species come in. But then another light gap forms someplace else for these to go over to the other light gap. And that is probably the best explanation. Our data really are supporting this moderate disturbance that's somewhere in between those two extremes. If you've got things going on that are moderately changing things and keeping things going so that the forest never all grows up or never all gets destroyed, somewhere in between, that's the best explanation for why there's so many species here, and that aspect of biodiversity is so important.